Warning, this video is not a how-to guide. This video is me sharing my experience of provisioning an S-Plan heating system which will undergo thorough scrutiny from a professional and competent engineer when my new boiler is commissioned. Hi, I'm David and welcome to the Retro Builder channel. This channel was created as I have a huge love for all things DIY. And with my home just recently turning 60 years old, I thought it would be great to start sharing some of the jobs that I get up to in and around my home. So sit back, get yourself a cup of tea and enjoy what we have in store for you this episode. Hi everyone, welcome back to episode 2 of installing an S-Plan heating system into my home, ready to accept a brand new boiler. So before we get into episode 2, which is going to be mainly focused on the wiring of all of the modules that are included as part of the S-Plan system, let's just update you with where I got to between the end of the last episode and now. So let's just get you over here and looking at firstly the board that we finished up working on our plumbing in the end of the last episode. And if I draw your attention to the flow and the return pipes, they look slightly different to how I last left it. I think we'd installed on the return the sludge collector, but now what I've done with the flow is kind of curve that and bend that over here and install a drain off valve. The reason I've done this is if ever I need to work on the 2-port valves, replacement for instance, we can drain off, if we isolate the water, all of that flow part of the system through here. We then curve down and go to a T-piece and we'll notice that we've got this mechanism here which is a bypass valve. I didn't know really anything about these until I stumbled across a diagram when I was looking at S-Plan heating systems, and I'm not entirely sure if it's essential for our boiler, but I thought I'll put one in anyway. And essentially it connects the flow and return, and if there's a loss of back pressure on the flow, for instance if your radiator TRVs are all closed off and you're really restricting the initial flow from the system, you can come through the bypass valve, which is adjustable by setting the pressure. But yes, we're pretty much there from a plumbing perspective. You know, most of the work was done in episode 1 and we're ready to send those pipes outside to where the boiler is. But in today's episode, if I draw your attention up here, we essentially have the mothership of chocolate blocks, which is here, and we'll have the controller which will command hot water and heating fix here. But really what we have to do in this episode is work out where all these cables go. It's worth mentioning that I did go through the rigmarole of lifting the upstairs hallway to get a cable down from the hot water cylinder, where I've gone ahead and installed the thermostat, so the boiler or the controller or whatever knows the actual temperature of the water in the hot water cylinder. So yeah, I've installed the thermostat. I went and lifted the carpet in the hallway, lifted up the floorboards, and I managed to run a cable from essentially the other side of the house down to here. So yeah, we can wire that into our mothership, which is the terminal block just there. In addition, we've got a few extra cables here. So we've got things like this will eventually make its way out to the boiler, which is a 4-core, because the boiler will have a constant live, constant neutral, constant earth, and then a switch live. The reason it will have a constant live is because the boiler lives outside. If, like today, being a very frosty morning, the boiler needs to command for its own heat, just to make sure it doesn't freeze up inside, it needs constant power. So yeah, we've got a 4-core cable which will go out through an isolator switch, and in addition we'll have the main 3-core live, neutral and earth going into the chocolate block, which will feed everything, the 2-port valves, the controller, which will come from a plug, and it will just be a 3 amp fused plug, which yeah, it will just simply plug into a twin socket that lives underneath here. Okay, enough jibber jabber. Let's just start chipping away at all of these cables. I think the first one to start with will be the actual 240 volt 3 amp feed. So we'll get a plug on that, and that will be 3 amp fused, and that will start feeding power to this, and then we'll start chipping away at everything that basically needs power, so on and so forth.
As mentioned, power to all of the bits and pieces which make up the S-Plan heating system, including the boiler itself, are powered by a 240 volt supply. I have an old Christmas lights plug which has a 3 amp fuse, which should be enough for the job. Absolute worst case, if this fuse blows when the whole system is up and running, I'll swap it out for a 5 amp fuse, because the flex cable I'm using is rated up to 10 amps, but most common central heating systems would never draw this much from the electrical source. With my plug wired in, I then cut back the insulation at the terminal block. Whilst I don't chase perfection, I think given the space is so tight, it's wise for me to have as little cable in this box as possible. So I cut the wires according to their curves and length relative to the terminal they're going into. Pop them in and tighten them up.
Right, so we're off to a flying start. To put simply, we've put a 3 amp fused plug on the end of this cable, which feeds our common live, neutral and earth. Okay, so they're going to go into 1, 2 and 3. Obviously these terminals are named, or numbered should I say, and then it's good practice to label each one. So I'll be labeling 1, 2 and 3 as our common live, neutral, earth, which means we can start with potentially our first appliance or module or component, whatever, which I think I will go for the controller. Now, if I bring the controller in front of your eyes, you'll see that it's pretty basic. It has obviously your buttons to advance your hot water or your central heating, or alternatively we can flip this flap down and essentially set a timer. But what that results in from a signal perspective is we have basically a neutral and a live coming in, which will power this unit, and then we have a signal going out for hot water. So if you look at terminal number 3 and terminal number 4, we've got hot water on or central heating on. We won't be using hot water off or central heating off. I think that's when you have a 3-port valve, but we're dealing with two 2-port valves. So essentially we need a 4-core cable, which we have. So we've got 4 cores here. We've got our essentially live, neutral, earth, and then we have another cable grey. But what we'll need to do is, because not only will terminal, 2 is live, 3 and 4, hot water on, central heating on, they'll be switched live. Okay, so when you command hot water or central heating using the buttons or the timer built into the programmer, live will go through the controller and then off to wherever you see fit, which means we need to decorate with this brown sleeving. So I bought some 3mm brown sleeving, and we'll decorate the 2 cables that we'll use for the switch live, which will go into these terminals. So yeah, let's get on and get that controller in place.
I think at this stage I'm really hitting a limit of what my basic cable strippers can handle, but we push on anyway. This 4-core flex is pretty thick, but I do manage to strip back the outer insulation, exposing the brown, black, greeny yellow and grey cables. Because the controller will be fed permanently by the brown cable, which I will use for live, and the black cable, which I will use for neutral, I decorate the greeny yellow and grey cables with brown sleeving to indicate it could be live. Basically, these will be our switch lives. After stripping back the cable insulation, I place each cable in their respective place and tighten them up. Then pop the controller onto the register plate. Then tighten the 2 retaining screws which live at the bottom of it.
Okay, so we've hit our first milestone. Let's spin you around and show you what I've been up to with the controller and the wiring. Right, so in those clips, obviously the first thing I wired up was a 3 amp plug, and then the next thing I wired in was the controller. So we've got a few of the cables already put into the chocolate block, or terminal block as we call it. But what does that actually result in? Well, let's show you. So let's take the plug, and first and foremost, I'm going to plug it in into any socket in the kitchen, power it on, and suddenly we see the controller come to life. Now obviously we've got green lights on, which implies that we've commanded for heat or hot water. But what does this actually result in us seeing? So we've obviously got our common live, neutral and earth, and then the controller itself has a live and neutral to it. It doesn't have an earth because it's plastic, so you don't need to earth a plastic appliance, and that gives it the power when we plug in, which is great. But then we've got, coming out of the controller, these 2 switched lives. So I've actually used, out of this 4 core, the earth and the grey cable, and I've used the brown sleeving to denote that it's live. But I've literally just dropped the screwdriver down the back of the dishwasher. Oh, I don't believe it. Right, as I was saying before I dropped my screwdriver, if we take our screwdriver, which obviously measures for voltage, and we put it on the cable that I've sleeved as a switch live, which is our earth cable, coming out of here, which is I think the 4th terminal or 5th terminal, and we hit heating boost, we can see the screwdriver lights up. Okay, and if we put it in again, turn it off, we can see the screwdriver turns off. So that indicates that we're getting a switch live from our heating circuit. And if we put the screwdriver on the other switch live, yep, and then we advance our hot water, it'll come on, turn it off, it goes off. So basically what we've evidenced there is whether we're advancing hot water or heating, or if I went ahead and set a timer, essentially this controller will now send the live coming into it out to one or the other cable, depending on whether it's hot water or heating. So what does that mean we have to do next? Well, it means if we focus on one circuit, so say our heating, we're going to now send our heating cable off to the thermostat.
The thermostat has 4 wires coming from it. It is plastic, so we don't need to worry about the earth so much. Looking at the wiring diagram, we can see we have a permanent live, permanent neutral, and a switch live which is known as cool for heat. Having removed my pre-existing thermostat, you can see only 3 of the original wires are used. I fix my new thermostat register plate to the wall. Then once wired in, I fix my new thermostat to the plate. Then tighten the mounting screws. Because the colours of the cables change from what was originally set into the wall, then through a junction box off to the terminal block I need to wire in, I created a wiring converter which clearly outlines what colour goes from what to where. I take this info and wire in the thermostat at the terminal block. Black goes to the common neutral, earth goes to earth, but as I said before, this isn't used. Brown is my live feed to the thermostat coming from the controller switch live that we demoed just earlier. And then the grey is the switch live coming out of the thermostat, which will be used later on. With the room thermostat wires plumbed in, I test it by powering on the controller, cooling for heat, and turning down the room thermostat. You can see I have a live at the grey cable. Because I'm adding more cables into the box, now might be a good time to start labelling what terminal does what, as it's only going to get more complex later on. With my room thermostat done, I figured I would follow suit and throw the water thermostat into the mix, which is exactly the same concept of a room thermostat, where we have a permanent live and a switch live. Then, to maintain traction, I figured I would throw both my 2-port valves into the terminal block, which are the last pieces to this wiring puzzle, which I will better explain how these actually serve the system now.
Right, so you saw in those clips that I finished off the final bit of wiring in that mothership terminal block, and what I'm going to do is spin you around and just give you an overview of the last few bits and how it's all now connected together. Okay, so taking you over to the area of concern, we've obviously plugged in our power and we've got power to the controller as we saw before, and before we wired in the 2-port valves and both the thermostats, essentially when we were hitting heat on any one of these, we were getting power to the relevant switched lives that come out of the controller. And then the question was, where do they go on from there? Well, in a nutshell, they go on to the thermostat, and then from the thermostat it comes back to one of the 2-port valves, and when one of the 2-port valves opens, that triggers a micro switch which connects 2 of the wires, and then one of those wires will go off and onto the boiler wire where I've put a test lamp. So you're probably thinking, well, that's not a boiler, that's a light. But the concept is the same, right? The only thing we care about is the switch live on this wire getting a feed when we command either heating or hot water. So a really quick demo is if we go and hit heating boost, we've already got the thermostat turned down. We see the 2-port valve starting to move, which will make a connection back to the mothership and turn on the light. So we know that essentially a signal would go off to the boiler and say, fire up, the 2-port valve is opened. So obviously that will allow water to flow when the boiler's running, and so on and so forth. And that is essentially it. So I can turn off the heating. We'll see the 2-port valve close, and the boiler, or in our case the light, will switch off. And that really is the same for the hot water or whatever zone you decide to add on to this in the future. Okay, so last explanation, and I find often a diagram really helps in these situations. So let's just focus on the live. Let's ignore the earth, ignore the neutral. They're all shared, and that's by the by. So we've got obviously our plug socket here, and we're just going to focus on the live, right? So a live comes from our plug socket and it comes into our terminal block here. Okay, so we've got a positive there, and then from that terminal block we wired in our little controller. Okay, and then when we say, oh, I want central heating, we have a live coming out of the controller back into the terminal block. Okay, and then from there we go off to our thermostat. Now obviously the key thing with a thermostat is you can say I want central heating, but if the thermostat's happy, it's not going to click. Okay, so a positive is coming in here, but when it's not happy, when the temperature in the room drops or drops beyond what we've set the thermostat to be, we then have another live, a switch live, coming back into the terminal block. Now at this point, if we've got a boiler down here ready to fire up, ready and waiting, yeah, there's my crude drawing of a boiler. What we don't want to do is just fire it up straight away, because this is going to have our flow and return pipes coming out, but we've got our 2-port valves, which obviously are essentially gates on the flow and return. So we've got, how do I draw this? We'll ignore the hot water for now, but we've got a flow going this way and a return coming this way. And obviously those gates, those 2-port valves, they need a live to open. So what happens is the positive from here comes out of the terminal block into here. So we've got a positive going in, or a live should I say. That's me working on cars for a long time. And then the 2-port valve, if I just explode that out, you've got a big valve with a pipe going through it. And we showed you in episode 1 that we have kind of like a flap which stops the water going through. Now when that flap opens, it actually engages a little micro switch, and the micro switch connects 2 of the wires on it. So if you've got a positive coming in, you'll then have a positive coming out. And what does that mean? Well, that then comes back out of the 2-port valve, back into our terminal block, and then that will go off to the boiler, which basically means the boiler will only fire when this flap or the valve is actually open, so it's ready to take water flowing through it. And that obviously is one of the 2 systems that I've got. I mentioned I've got hot water as well, but this is the central heating, and that's kind of how all the components are connected. Okay, so really that is it for this episode. We have all of the components wired in and working with our test lamp. So in theory, it would be ready to fire up a boiler. However, there's still a lot more work to do. We need to go outside in the next episode and start working around the boiler. 1, we need to clear the area. 2, we need to get oil to the boiler. 3, we need to get the flow and return pipes from inside the house to the outside. And there is a pre-existing hole I think I can use for that. And to my disappointment, I made a discovery this morning when I opened up the boiler casing just to have a little look that it does not have a central heating pipe within the boiler. I thought for the best part of £2,800 it would have included it inside the boiler, but it doesn't. So that's okay. When I did scrap my old boiler, I retained the old central heating pump, so we'll be plumbing that in as part of the wiring, but that'll be in the next episode. So I hope you've enjoyed this series so far. That's 2 episodes in, and we have a final episode before we get an engineer over. Obviously, if you enjoy the content, hit the subscribe button. That would really help me out. And thank you so much for watching, and I hope to see you in the 3rd and final episode. But until then, have an amazing new year. See ya.